Hey everybody, Blake Bailey here with another Knower LMS module. Today we're going to be talking about AC stator winding failures, but before we do that, a little bit about me. I'm with a member company called Design Motors and provide engineering design services to motor manufacturers and motor service centers, just like where you work at. And today, just going to be getting into these winding failures to hopefully share some knowledge and learn to speak the same language a little bit more in this industry we all live in. So again, this module is going to be AC stator winding failures. It's the first module in this series. And for the introduction here, all the modules have the same basic format. And today we're going to do just like we will in all of them. We're going to go over your safety considerations for doing this job and documenting these observations well. We're going to talk about the tools that you're going to need as you do this process. We'll talk about the different components you observe, literally the parts of the motor that you're working with and you're observing. We'll talk about the conditions in those components to observe. In this case, the failures of the windings and what they might look like. We'll talk about documenting those observations. What kind of forms do you need? Who do you need to let know what failures you see? How do you communicate those things? And as always, we'll end by talking about some references or some further reading you can do if you want more education. And as far as that goes, this is really meant to give a high level overview of this topic. We're not trying to dive real deep on every single section. So just remember that. But if you have questions, I encourage you to get with the technical advisors at your member companies or folks like me. We'll be glad to talk about this. A lot of this is on the job stuff that you're going to learn. But today we want you to be familiar again with those the tools, the components, the conditions, how to document those things, and how to be safe while you're doing all of it. So looking at safety considerations, talking about electric motors. So the electrical hazards are a big deal here during the rewind process. So you can have items like residual charges in your test equipment. Less often you'll have some residual charges in some of the actual motor components, but you've got to be careful with these electrical shock hazards. They're real and they can vary from a few milliamps to thousands of amps according to what kind of equipment you're working with, and the voltage levels can be considerable. So you can see in this example photo we got here, you have one operator in there with a high voltage test they're performing. Everybody else has to be behind a cage because the higher you go in voltage, the further these things can jump. And so you've got to be careful. Looking at your PPE, your eye protection, skin protection becomes important. There's a lot of sharp points in stator windings, and especially when you talk about dissecting coils and getting into inspecting these windings. So be careful with that. Items like respirators can be important because we've got these insulating materials that, especially after the motors are burnt out for analysis and or rewind, there's going to be a lot of dust that gets created. It can be from fiberglass, the different varnishes that are used. So that respirator is going to be very important. Anybody that's been around rewinds knows the feeling of having insulation stuck in your skin after a burnout's happened and you're pulling the coils out, or having that dust get in your lungs and coughing it up for days after. So pay attention to the basic PPE and especially the electrical shocks, your respirator during the rewind and burnout process, and protecting yourself from the sharp points. Talking about tools, there's a very long list I've got here. I'm not going to read the whole thing, but some of the highlights are items like your electrical test equipment, cameras, your cleaning supplies, and the dissection equipment. Your testing equipment's really going to be dictated by industry standards and the standard shop processes that you have. So, for example, we've got a picture of a high potential tester here, one of these industry standard testers that you've got to use to analyze what's going on in windings when they failed, and you also use them as qualification points for new windings. So there's going to be a few pieces that are pretty common. You've got your Megger, your insulation resistance testers. You've got your high potential testers here. You have surge testers looking at patterns that you have in different groups of coils. You've got ohm meters, DLROs, which are digital low resistance ohm meters, which record the small resistances that you can have in some of these windings and these motors. Second one on this list is a camera, and pictures really are worth 1,000 words in the service industry. You want to document these things well, and I don't believe there's anything such as too many pictures in this process, so take those pictures. Measurement tools, obviously, so we have a person using a tape measure here to measure a cutoff end winding on a large motor. And tape measures are good for a lot of basic analysis and rewinds, but when you need to start ordering replacement laminations or some of those more critical components, you're going to need a good set of micrometers and calipers, those kinds of things. And basically your visual inspections coupled with some of these basic measurement tools are going to get you there most of the time. Okay, you can see the rest of the list here. Talk to those technical advisors at your company if you've got more questions about these tools, but it's a pretty good list we got. Looking at the components to observe. Again, we're talking about stator windings today, and specifically in AC electric motors. And as you might know already in these presentations, we talk about motors almost all the time, but you can interchange that with generator, because motors and generators are basically the same thing. The electrical and mechanical workflow is just backwards from each other. So anyways, talking about these stator windings. These are the most common electrical component to fail in motors, and most rewinds do occur because of these winding failures. And in fact, all of them do, because whether it's the winding's fault or winding practice's fault, if your winding isn't working, your rotor's not turning, your motor's not doing its job. So just remember that there's been a lot of industry studies done, but these stator windings are the most common electrical component to fail in your motor systems, a lot more common than rotor failures. So it's important to learn what to observe here. So I can turn my laser pointer on here. And look at your stator windings. There's a couple of main types of windings we have, and there's also a few main components you want to pay attention to. Look at these photos. This image here on the right is what we call a random wound or a mush wound motor, typically used in low voltage applications below about 1,000 volts. On the left here, we've got what we call a form wound machine that would be used typically about 1,000 volts. Your 2300, your 4160, your 6600, even your 13.8 kV machines. You're going to have coils look like this. And looking at each of them, you can see you've got common components. You've got your end turns here. This is the portions of your stator coils that go from one slot to another. And you can see we've got that here on this random wound machine that's failed. And you can see here a little bit better the end turns on this form wound machine, again, going from one slot to another. You've got your lamination sections here that actually form the shape of your stators, and they make up the slot portions, the OD, the ID that the rotor sits inside of. So laminations are always here in the center. Individual sheets compacted together to form one solid mass. And then, of course, you've got your windings that continue through the slot portions here. So again, remember, you've basically got coils that go through slots in the stator, come out, go to another slot, and return. Obviously, you have lead cables and terminations and lugs that will be found in the junction box of the motor to connect to your customer connection points on site. And you can see some internal leads here on this machine, but won't go too deep into those right now. The internal connection points are something that we should pay a little bit of attention to, and I'll use the form wound machine here as the first example. Looking at this, we talk about jumpers. You'll hear this word thrown around on winding floors a lot. So basically what jumpers are, they connect two different windings or two different groups inside of a motor. So you can have what we call coil-to-coil jumpers. So you can see this would be an example right here of where these coils have an entrance and a return lead. So the voltage and current has to come in one side of the coil, go out the other, and go to the next coil. And that's what these coil-to-coil jumpers do. They connect the exit lead on one coil to the entrance lead on the next coil. And they'll be real short and small. You can see that here. The other kind of jumpers we have are group-to-group jumpers. So they can be short, they can be long, but they'll all be longer than your coil-to-coil jumpers. And that's kind of the main distinction for the first-time observer. So you can see here, this would be an example of your jumpers going between groups here and here. You can see they're a lot longer than the coil-to-coils. The other thing you have is you have your lead connection points. And this is a good photo to show this here on this form wound high voltage machine, where you get your exit off of one of the coils and it immediately comes out to these rings external to all the other connection points. That'll either lead to the external leads or perhaps a Y point, a Y connection or star connection inside of the motor. But many different kinds of connections, and you can see the same thing if we zoomed in on this random wound machine, but they're a little more difficult to see because coils are generally more compacted together. You can see the main lead exit here, but that's kind of it in this picture. And when you're observing these components, you want to also look at the nearby things. You want to look at your frame on your motor. You want to look at the bearing brackets that are adjacent to the windings, and just look for any obvious signs of failures in those components to help you understand what's going on. Talking about conditions to observe. Now looking inside of these windings, the specific things we're looking at. So this is really where we start talking about the different kinds of failures you can see. So I've got this slide, I'm calling it conductor-related failures. And really what I mean here is the failures that can happen because of what's happening in your winding. We got the main categories here being turn-to-turn failures, phase-to-phase failures, ground failures, and connection failures. The turn-to-turn failures. This is one that really it can show up in a lot of different ways. And you can have machines that start with a turn-to-turn failure that leads to a phase-to-phase failure or possibly leads to a ground failure. But the important thing to know about turn-to-turn failures are they happen from literally one turn to another. So in your random wound machines, like you'd have here on the left image, they'd be perhaps when someone was winding this machine, they nicked a wire as they were making the coils, and the insulation isn't present on the wire. So now you've got a degraded barrier between one turn that's got this degraded nicked wire to the next turn, right? So over time, you takes a lower threshold for the voltage to jump from that one turn to the next turn. So they could start like that. Perhaps you've got overheating in a machine that's more widespread that wears down that conductor insulation. So you got turn-to-turn failures to start there. But the point is, they'll usually start interior to, they will start interior to the winders, but they'll usually be something small. They can be hard to see at first. And but the thing about them is they can quickly escalate. So you have one turn-to-turn failure and it can create localized heat. Well, that localized heat is going to degrade the insulation on the turns beside it, which can then degrade the other ones beside it because of the heat building up. And eventually you can have a ground failure, right? You have a turn-to-turn failure in the slot, degrades all the insulation around it. That voltage can find its way to that stator core. You have your ground failure. Same thing can happen in the interns, right? You could have failure of one conductor to another that leads to something that blows up in the interns. So I spent some time on the turn-to-turn failures because they're very common. Sometimes you can catch them early, but usually if a turn-to-turn failure is allowed to develop at all, it's going to turn into something catastrophic. Looking at your phase-to-phase failures, those are the failures that'll be visible often in coil extensions because that's where in slot sections where coils of different phases are touching each other. You'll see those because the phase-to-phase voltage differential can be very high. It's a lot higher than turn-to-turn voltage differentials. So these failures can also be pretty catastrophic. They'll be pretty high energy. And like you can see here, you've got molten copper present. And that would be indication, that it was a high energy something. And it's out here on the interns. This is phase-to-phase example right here. Ground failures, those are the ones I was talking about that typically will be going through your stator core because it's the closest ground point to your windings almost always. They'll usually involve some kind of localized damage or discoloration. This would be a good example looking at this image on the right here. They'll be, again, adjacent to or in the stator core almost always, and there'll be signs of some other failure usually present, whether it's a turn-to-turn, some stator core damage, something like that. And you can see here, they can have enough energy, just like phase-to-phase failures, where they can literally blow out portions of your stator core or something adjacent to them. So be pretty catastrophic, but they're, again, usually starting with something like a turn-to-turn. Connection failures, the last part I mentioned here, this will often be visible discoloration in connection areas. Could be between the coil-to-coil jumpers we talked about, could be the group-to-group jumpers, could be at the lead connections. And there's often other failure modes that are present once your leads fail because it'll send some kind of transient through the rest of the machine. Is your pointer gone? Apologies. So coming over here to the conditions to observe, we're going to talk about component failures now. We talked about those conductor failures, but now the things that are around the windings, right? So we talked a little bit about leads in the last slide, but getting a little more specific on your lead cables. Lead cables can fail for multiple reasons, just like everything in your motor. Some of the most common failures you'll see with leads are where the leads exit the winding and have to make a turn into the junction box through some feature on the frame that's on that stator core. Often they'll get abraded on sharp metal edges. Other times your leads can just get old, right? They're in a different environment often than the inside of the machine. You can have moisture intrusion problems, right? Maybe your junction box isn't as well protected, or it's an aftermarket junction box that allows moisture to build up and soak in those leads and they swell and fail. Bend radius can be an issue. You don't want to have too tight of bends in your leads. Wedge issues. That's the the components in the slots that prevent those coils from getting out of the slit that comes into the stator bore. So slot wedges can have a lot of issues. You can have loose wedges that can eventually abrade and degrade and disappear. They can be loose enough to where they literally come out. They can slide axially sometimes. Some machines, usually larger machines, will have what we call magnetic wedges that can be kind of putty sometimes, that helps you with a lot of the electromagnetic design, but then can be a nightmare for maintenance and reliability in your machine. So watch out, check the condition of those wedges. They should look uniform across the machine, and they should absolutely be present. There's other insulation failure issues you can have. Talk about aging and degradation. You get an old winding, the insulating materials can get brittle, right? They get old. They can literally lose their ability to insulate electrically over time. Abrasion can be a problem, moisture intrusion, a whole list of other things. Talk about structural component failures. As in this example here, we've got a machine that you can see these fiberglass strings basically hanging off these bolts. And what happened here is we had a catastrophic failure in this motor where the baffles literally have been blown away, burnt away, destroyed in some manner that this machine now needs new baffles to be made to direct airflow and to keep that winding nice and cool. There's also supports you can have for those rings we saw in the slide where we're showing the different types of connection points. You can have your surge rings that can degrade. You can lose the structural support back to the stator core for those. Lots of component failures that can happen. But again, these are the things that are going to happen that aren't directly related to your winding. Finally, looking at some other general failure categories, contamination would be the first on the list. There's a wide range of different contamination issues you can have in motors. Usually contamination issues are going to be pretty uniform across the winding, right? And they should lead you to questions like, what's the enclosure on this machine? What's the installation environment? Is the contamination that's on the winding easily identified? For example, I look at this picture on the left here, and I say, well, it's a pretty uniform contamination on this. Is it salt? Is this some kind of cellulose fiber from a paper mill? Does it make sense in the environment, right? You look at something and the color's wrong, you say, okay, does this line up with what's there, or could this be some other issue, right? It could be oil from the bearings. It could be salt, dust, you name it. We've seen all kinds of things on windings. Overheating is also another issue, and that'll generally look like some kind of discoloration. You can see here we've got a winding that actually wasn't varnish treated, and you can see the difference in color between these different coils. And that dark color is literally a sign that this particular phase in this motor was overheating. So overheating issues can lead to a number of other problems in your motor, so watch out for them. And then there's a multitude of other failures you can have. This particular one being an example of a lightning strike. You can see where we've got one spot that the transient that happened because of the lightning strike on site found its way to ground out here in the interns into the stator core. So many failures you can have, but again, that first slide we talked about with the conductor related failures is really the thing to key in on, and it's going to help you really develop your skills as a rewind technician or just someone working in the motor industry. So moving on now to documenting observations. So there's several things that you want to document well. We talked a little bit about this at the start when we were talking about the different tools you're going to need, but your documentation is going to be a big deal for your future troubleshooting of problem jobs. It's going to help you avoid warranty claims with your customer and also prove the work that you might need to do during a rewind or recondition of your motor. So documenting these observations is just as important as finding out what happened with your motor or observing what happened, because the proof long-term is going to help you out a lot. Again, just think long-term for your customer. Don't just think about today. Document things well, and you'll thank yourself later. So looking at the electrical testing results, you're going to have different checkpoints throughout the rewind process. You're going to have some incoming results that you're going to document. Maybe it's the general resistance of the winding, incoming mega results, resistance results, some photos. You're probably going to do another round of testing after you clean up a winding, or possibly after you remove some coils or dissect that winding. And you should have standard shop forms that you're doing all of this on, right? You should have forms that are going to look the same for whatever job you're doing, so that your technicians know what they're looking for, your customers know what to expect in their repair reports, and your work is that much easier to do, right? So, we talked about those tools at the start, but your standard electrical tests are going to be your Megger, your surge, your high pot, your resistance. And then if you're looking at the lamination conditions, your core loss testing. Photos, second thing on the list here as well. One big thing I'll say for you folks working in the repair industry is photos in focus. So repair shops it's a dirty environment often, right? So technicians are working through things quickly and in a dirty environment, right? You got gloves have grease on them from disassembly, that kind of thing. But make sure those camera lenses are clean and make sure you're taking pictures that you watch the viewfinder, make sure what you're trying to take a picture of is in focus, because it's one thing to say I took pictures and then somebody goes back and looks and they can't tell anything other than you got some kind of orange and gray blob, right? But if you've got in focus pictures, they're going to help you. Again, you're thinking about documenting what you did well for your shop and for your customer, right? So take good photos. And I recommend taking standard photos for every job, right? Maybe you decide that, hey, for every single stator that comes in, we're going to take one picture looking at each end of the bore for the stator, and we're going to take a picture on each side of the stator, whether it's inside or outside of a frame. We're going to get pictures of the connections. It's probably a good idea too. And then obviously you want to get zoomed in or close-up photos of your failure areas, and then pictures following any destructive testing or coil dissections that you do. Your winding measurements are also important. Your shop should have standard uh, stator core and stator winding, stator coil forms that you're going to document maybe the overall length of the coils with, the coil to coil spacing on form wound jobs, maybe your lead lengths, your lead size, that kind of things. You want to, speaking of leads, take good information down your leads, right? You want to know what's the material they used. It matters a lot. We talked earlier about lead degradation. It's a huge problem in industry, and it can cause, you can fail an entire assembly line because of a small piece of cable that's the wrong material. So pay attention to what they are. Pay attention to the length. You don't want your customer to come up short, and you also don't want your shop spending too much money on this expensive lead cable that your customer didn't need 3 foot of, but only needed 12 inches of, right? And so in basics, I say the count of leads, the size, the type, and the general condition. The terminals and the lugs, sometimes you're going to send jobs out with lugs on, sometimes you won't. It's kind of a customer preference thing, but if they come in, you should at least document what was there in case you do need to replace them. Then obviously you're going to document the different kinds of failures you had. And here, this is a good example here. I've got a couple of pictures. This on the right would be one standard form. I believe this comes out of an ESA recommendation, one of their documents that just has, again, standard items you're taking data on for every stator that's rewound or worked on. And then over here, we've got the polarization index test results coming off of a modified Megger or insulation resistance test. So again, you open up your job folders on your computer or physical ones, and you should see the same results, same kind of photos, same documenting practices every single time. So getting towards the end here, talking about references and further reading, there's a lot of good data put out by ESA, the Electrical Apparatus Service Association, that your shop is almost certainly a member of. So check out things like their technical manual. It's a very large document with a lot of good information developed over decades. There's the ESA AR100 standard, that's a repair standard. It's got some good just kind of checkpoints in your repair process and good qualifications and specifications for the work that you're going to do. There's also the ESA AC motor redesign data and program that they have that you can open up, and it kind of tells you the things to look at when you're dissecting windings to know that, hey, if I make changes because I had this certain failure, what's it going to do to the performance of this machine? And then finally, this list isn't any longer because a lot of this becomes just on the job training. Hopefully things like the learning management system, the LMS modules that NOAA's putting together right now help you start your education and further your education. But a lot of this is going to be on the job training, right? So get in there, get your hands dirty, pay attention to what you're doing. And of course, if you get questions, go to those technical advisors at your shops. Folks like me that are members of NOAA will be glad to answer your questions as well. But this is a wonderful industry to be part of, and these stator winding failures, being the most common failure, are really important. So getting out here to the end again, this is something that NOAA's putting together so that we all speak the same motor language and we're all doing our part to learn every day. And thanks for taking time with this AC stator winding failure presentation. And at this point, you can proceed on to your module assessment. Let's see how you did. Let's see how much of this you took in. And again, thank you for your time and wish you the best today.